Below -50 degrees Celsius, metal becomes brittle. Diesel thickens. Skin freezes in minutes. At 5:30 in the morning, the air outside registers near -70 degrees Celsius. A father steps into the darkness, breath instantly crystallizing, boots creaking on snow hardened like stone. He wears 3 layers of wool and a parka lined with fur, but the cold presses through in seconds. In his gloved hands, metal tools feel like ice blocks. At these temperatures, steel can fracture if struck too sharply. The handle of his axe is wrapped in cloth, not for comfort, but to prevent skin from freezing to it on contact. He moves quickly, hauling a block of river ice toward the house. Water cannot be piped underground. The soil is permafrost, frozen to a depth of hundreds of meters. Pipes would burst in minutes, so every drop must be harvested, carried, and melted by hand. Diesel in the generator tank is treated with antifreeze and kept in a heated shed, but even so, it thickens and flows sluggishly. If the engine stops, restarting it is a race against time. Below -40 degrees Celsius, diesel fuel gels and batteries lose their charge in under half an hour. Vehicles are left idling, block heaters running, because a cold-soaked engine can crack from thermal shock. The father's exposed skin is covered. At these temperatures, frostbite can set in within 2 minutes. Eyelashes freeze together. A flashlight battery dims after 10 minutes, drained by the cold. There is no margin for error. The sun will not rise for hours. Every action is dictated by the physics of extreme cold, how long a person can work, what materials can be trusted, how fuel must be managed. Here, winter is not an event, but the baseline condition. Every system, every daily task, is engineered to survive these limits. Homes in Oymyakon appear to float above the frozen earth, standing on concrete or steel piles that reach 2 meters high. This design is not a stylistic choice, but an engineering necessity. The ground beneath is permafrost, soil and rock, locked in ice year-round, except for a thin, active layer that softens each summer. If a building's warmth seeps downward, it can thaw the frozen base, turning solid ground into unstable mud. Over time, this hidden process causes walls to tilt, floors to crack, and entire structures to lean or collapse. To prevent this, houses are raised on stilts, creating a ventilated crawl space where frigid air circulates freely beneath the floor. This thermal break keeps the permafrost cold and stable, even as living spaces above are heated to comfortable temperatures. The gap must remain clear of snowdrifts and debris, which could block airflow and allow heat to build up. Residents routinely shovel out the crawl spaces after storms, treating this task with the same discipline as clearing a chimney or checking a boiler. Insulation is another line of defense. Exterior walls and roofs are built with double layers packed with mineral wool or polyurethane foam, achieving U values as low as 0.18 watts per square meter per Kelvin. Windows are triple glazed with low emissivity coatings, further reducing heat loss. Any breach, a cracked seal, or a gap in the cladding can become a weak point, letting warmth escape and risking a slow, silent thaw beneath the house. Maintenance is ongoing. Each spring, as the active layer shifts, foundation piles are checked for vertical settlement using laser leveling tools. If a stilt has sunk more than 5 millimeters, the entire structure is jack-lifted and re-leveled, a process that can take several hours but prevents long-term damage. This annual regimen is as routine here as changing tires for winter. In Oymyakon, stability is not a one-time achievement, but a continuous process, engineered into the rhythm of daily life. Steam curling from the central boiler plant marks the heartbeat of Oymyakon. Ivan Petrov, senior engineer, checks the pressure, 1.3 megapascals, holding steady, while the coal feed pumps thrum. The main boiler is a modular 7.5 megawatt unit, running with a backup burner rated at 2.4 gigacalories per hour. Both rely on high-sulfur coal from Jebariki Haya, stockpiled in insulated heaps for a 2-week buffer. Redundancy is essential, and if the main burner fails, the backup fires up within minutes. Diesel generators stand ready for critical buildings, and wood stoves linger as a last line of defense. Ivan's routine is precise, monitoring boiler temperature, adjusting fuel, and scanning insulated pipe loops for leaks. These polyurethane-coated steel pipes, suspended above permafrost, form a closed circuit. Any failure risks freezing, structural damage, and destabilized ground. Water comes by a different route. At dawn, Ivan's family and neighbors cut meter-wide ice blocks, each weighing nearly a ton, from the Kolyma River. Stored in -20 degrees Celsius caverns, these blocks melt slowly, supplying water for drinking and washing. Heat and water here are the result of engineering and constant vigilance. Convoys line up on the Kolyma highway before dawn, engines idling in the dark. In Oymyakon, every delivery depends on these disciplined processions: fuel, food, spare parts. Trucks travel in groups, each vehicle equipped with VHF radios and GLONASS trackers, maintaining constant contact as they cross frost-heaved stretches and brittle snowpack. Drivers check in by radio every 30 minutes, a routine that becomes more frequent if a storm rolls in. The unwritten rule is simple: no truck is left behind. If a vehicle breaks down, the nearest in line pulls alongside to share a battery or heated fuel line, and the convoy halts until the problem is solved. This mutual aid protocol is not just tradition, but necessity. At -60 degrees Celsius, isolation can be fatal. Road maintenance is an ongoing battle. Crews work through the night, filling cracks with gravel and laying geotextile mats over buckled sections. Repairs for frost heave are measured in centimeters. Any deformation over 50 centimeters triggers immediate attention, often with graders and thermal blankets. Schedules are compressed by the brief window of usable daylight. School children prepare for the walk to class before sunrise, layering wool, fleece, and windproof shells in a ritual that takes as long as breakfast. Caregivers check every zipper and scarf, knowing that exposed skin will freeze in under 2 minutes. Artificial lighting programs in homes and schools compensate for the darkness, set to mimic natural daylight and help maintain alertness. Every movement, from convoy departure to the first bell at school, is coordinated against the clock and the cold, each step a practiced response to environmental limits. Sergei arrives at his workshop before sunrise, breath lingering in the frigid air as he unlocks the insulated engine shed. In Oymyakon, every engine, whether truck, tractor, or generator, has its own shelter, lined with foam panels and heated by waste exhaust diverted from a constantly running motor. The temperature inside hovers just above freezing, enough to keep lubricants fluid and batteries alive. Sergei moves with practiced efficiency, checking the logbook for each vehicle's last warm-up cycle and part replacement. Overnight, block heaters have kept engine blocks above -40 degrees Celsius, but before any machine is started, he runs a preheat sequence: electric coils, fuel line warmers, battery blankets. Diesel is drawn from a heated tank mixed with antifreeze additive at a precise ratio logged daily. Sergei rotates spare starters and alternators into service before failure, swapping them out on schedule rather than waiting for a breakdown. Preventative discipline is non-negotiable. If an engine stalls in the open, even for minutes, recovery becomes a major operation. Each morning, he signs off on the maintenance sheet, confirming that every moving part is ready to face another day, at the edge of mechanical possibility. Sanitation in Oymyakon relies on engineering that acknowledges the impossibility of buried pipes. Latrine modules stand above ground, built from galvanized steel and set on insulated concrete slabs, kept just above freezing by waste heat from the central boiler. Each unit is sealed tightly to prevent drafts and minimize heat loss, and interior surfaces are designed to resist condensation and frost buildup. In winter, waste cannot be flushed or drained. Instead, it is compacted into heavy-duty drums stored in exterior sheds, where the contents freeze solid until spring thaw allows transport to incineration sites in Tomtor. The sanitation crew follows a strict routine, inspecting seals for leaks that could let in cold air, monitoring slab temperatures, and recording indoor humidity levels, since excess moisture can encourage mold even in the cold. These above-ground systems function as a closed loop, engineered to prevent contamination of the permafrost and to maintain public health through the longest, darkest months. At minus 60 degrees Celsius, the margin for error narrows to a thread. During a cold snap, a sudden drop in pressure triggers an alarm in the heating plant control room. The automated system isolates a segment of the pipe network before water can freeze inside, rerouting flow through an auxiliary loop. Within minutes, a team of volunteers gathers at the affected site. They haul preheated water drums and assemble temporary heat exchangers beside the exposed pipeline, working in coordinated shifts to keep the area above freezing. The central boiler ramps up output by 15%, burning diesel reserves to sustain pressure. For 2 days, homes and the school rely on this patchwork of emergency heat. The incident prompts a review. New pressure sensors are installed along the network, and a community drill program is launched to mobilize rapid shelter. Even with layers of redundancy, the system's limits are clear. The cold tests every link, and only collective action prevents a cascade of failures. In Oymyakon, cold is not an emergency, but the baseline for every engineered decision. As global infrastructure faces new climate extremes, these systems offer a blueprint, and resilience is designed, not improvised. The true test is not how we endure winter, but how we prepare for the cold we cannot avoid.